Okay, so what factors affect lime requirements? There's several. And by lime requirements, I mean how much lime do you need to actually add to increase the soil pH? So there's several factors. First one is the initial soil pH. So that's the indicator of the current soil conditions. Is it pH 6.5? Is it 5.5? Is it 4.5, etc.? So you need to know a starting point. Then you need to know what your desired pH is. And that's the pH that's typically optimal for whatever plant or crop you're growing. So it's dependent on crop species. It's dependent on that big table that I share with you in PDF format at the beginning of this unit. It's posted in Canvas or Carmen Canvas. And so the target pH values are generally for mineral soils, soils that contain less than 20% organic matter. They're typically lined to between pH 6 to 6.5. And in Ohio, our range is 6 to 6.8. And if you're dealing with an organic soil, a soil that contains more than 20% organic matter, typically we line these to between 5 to 5.5. And in Ohio, our target's 5.3. Now, you don't need the alignment as high as a mineral soil because there's very little free aluminum or aluminum on any of those organic exchange sites. So you don't have to deal with aluminum toxicity in these types of soils. Another point or factor that affects the lime requirement is the buffer capacity, right? We talked about this already, but as you increase cation exchange sites or organic matter, that increase in both of those requires a greater amount of lime to attain the same pH. And so here's some examples. We're going to talk about cation exchange capacity in the next unit in more detail. But here's pH on the x-axis and lime added in tons per acre on the y-axis. And you can see that the change in pH as a function of the amount of lime takes essentially more lime to change an initial soil with a high CEC or buffer capacity to change from 4.5 to say 6. It takes a heck of a lot more lime to do that with a soil that has a cation exchange capacity of 25 versus a soil that has a cation exchange capacity of only 5. And if you look, I have these designated as this would be a sandy loam, a silt loam, and a clay loam. So the soil is coarse textured to fine textured. And that is exactly how this works in soils in terms of liming requirements. You need more lime to change the pH with soils that have a higher cation exchange site and soils that certainly have more organic matter as well. The lime quality matters. If you have lime that's pure versus impure or contains impurities, it's going to take more lime with a liming agent that is impure as compared to pure. And all of this is tied directly back to either one of two of these graphs, right? They both basically tell you the same thing. This graph on the left-hand side that just popped up is inverse of the graph on the right-hand side. So the amount of lime that you add plus the lime that's either pure versus impure, it's going to take more to change soil pH in soils that have a high CEC as compared to soils that have a low CEC.